Hey guys, so this lesson is going to be sort of easy today because it is a combination of some old stuff, some new stuff. You're really just using equations and plugging in. So you're really evaluating algebraically, which is something you've done in Algebra 1, and we're just tying it into geometry. I would say one of the biggest challenges for most students is actually drawing pictures. So I will be giving some pointers for that. I will be pointing out the formulas that are given on a traditional formula sheet, and I will sort of talk you through doing it maybe in a more general way. So here we have example 1, which is the volume and surface area of a cylinder. In the box right here, we have the formula for this, I should have probably written it the other way, huh? So this is the surface area, and this is the volume. So let's add that to this sheet over here somewhere. So I'm going to write in this box, and you kind of doing your notes like me, maybe follow along. So what I did was I found a formula sheet online, and I also found a worksheet. Then I cut them up and kind of taped them into a notebook so that each formula section would have an example to go with it on that same page. And there's already pictures here, but I'm going to redraw each picture, and I advise you do the same because I think it would get you to be a lot better at drawing your geometric prisms. So this box we just said would be then volume. Okay, now I mentioned about doing things in a more general way, so we can generalize some of these equations for volume, for surface area, and that would be similar to when you know how to do something, right? And you're like, well, I don't need an equation, I don't need a formula, I just know how to do it. Okay, beautiful, perfect. A formula, though, will come in handy when the shapes are not traditional, or when you're not asked to find the surface area, or you're not asked to find the volume, but instead you're given volume and you have to find, the lateral height, and you have to find a radius of something, whatever. So these things get to be very tricky. So you definitely want to make sure you are comfortable and familiar with all aspects of volume and surface area. So before we start, for good measure, for practice, what I'm going to do is really underneath the given formula, I'm going to rewrite everything and I'm going to redraw the picture. When you draw a cylinder, we know that the top, hopefully from younger days, we know that the top and bottom of a cylinder are actually a circle. If you asked a small child what shape they were looking at right here, they might not understand that this represents a 3D image, that to them, this is going to be an oval. And I don't blame them, because by itself, when I just draw this shape, it is an oval. But once we start looking at this shape from the perspective, literally a perspective of a cylinder, like you're standing off to the side somewhere, right? And your eyes are looking in the distance, and now you don't have a bird's eye view of the cylinder. You have a view from somewhere so many miles or feet or yards this way and this way. So I start off with an oval. Then we're going to draw 2 parallel lines. Now, it's important to mention that this is not just any cylinder. This is actually what we call a right cylinder. So I'm going to make my height a little bit bigger so I could really show you what I mean by a right cylinder. Then I'm going to draw another oval on the bottom, or we might call this an ellipse. But when I draw it on the bottom, I will make it solid on the front of the cylinder, and I'm going to make it dashed on the back. Some people have a very hard time drawing a dashed and solid oval. They need a fluid, like one fluid sweeping motion to make their ovals. I get it. Not everybody is an artist. That's fine. So if you use pencil and then erase, then do that. I like to use dotted lines, dashed lines to represent the lines that are not in the front of the image, where I can see or touch them from where I'm standing, okay? Now, the height of this cylinder, we can look at the height as being right over here. We could also look at it as being right over here, or probably best, we can look at the height as being right over there. That right there is the height of the cylinder as well. This is slightly better because when we start doing things that are cones or pyramids, these are things that taper and come to a point. You can't really have a height out here that's standing up vertical, perpendicular to the base. Could you draw an invisible line? Absolutely. But the height goes from the vertex of a pyramid or a cone, which we'll see soon, down to the center of the base. Now, I mentioned that this is a right cylinder. People read that phrase sometimes, like say on the SAT or something, and they end up drawing a Capri Sun pack for the picture, kind of. I don't know, I always compare it to a Capri Sun, something like this. As if it's like flat down there. That really doesn't make sense, okay? So let's not do that. Now that you've seen what I mean, it is not that. Let's draw the no symbol. Instead, it's going to just make a right angle with, now you could say it makes a right angle with the base, or you can say it makes a right angle with the radius of the base, however you want to think of it. So now the radius, this dashed line that connected from the center to the circumference is the radius. Another thing that gets tricky for people is the radius is not going to look like the same length from every angle. For example, this is also the radius. If I measured this with the ruler and this with the ruler, they would be different, but I promise you they're both the radius. If you are struggling with visualizing things in 3D, that's okay. There are a lot of people that have a very hard time picturing two-dimensional objects as three-dimensional objects. It actually is not easy. If it comes easy to you, you're very lucky. But if not, just take your time, try not to get too frustrated, and you'll get better at it the more you practice. So this right here is the radius, and I could also say that this line is also the radius, and I will color it in 1 second, but I just need to be able to fit everything, and I'm going to give that a color. So I will use, I guess orange. So right here, I could look at that as the radius, or I could look at that as the radius. There we go. Now, if you look up again at the surface area and volume formulas, they really only require a radius variable, radius height. That's it, right? Like radius, radius height, radius and height. Pi is not a variable. Pi is a fixed value. It's an irrational number, 3.14, yada, yada, yada. And we're going to talk about what all of these pieces mean in this next phase right now. So now what I'm going to do, now that I redrew my picture, I'm going to find the, rewrite the surface area equation. When I rewrite it for practice, because I want to be a superstar student and memorize my equations and know them really well, so I'm going to write out surface area of a cylinder. Well, maybe I should put the R. There we go. Surface area of a cylinder. I like to use SA as my abbreviation for surface area because I think A is just area of a two-dimensional object, and now we're looking for the area all around the outside of a three-dimensional object. Where did this list of information come from? The surface area is really going to be the top the bottom and this outside part. This outside part has a shape that we can assign to it, as do the top and bottom. So I'm going to write top plus bottom plus, I guess I have to give you the vocab word now. So this outside area, because I don't want to say outside because the top and the bottom are outside as well, right, is called the lateral area. So that's what that lateral surface is referring to. What shape is the top of a cylinder? Circle. What shape is the bottom of a cylinder? Also a circle. What shape is the lateral area? If I had this made out of like stiff paper, what shape would be the piece of paper responsible for making this lateral area? I'm going to go with a little scissor. We're going to cut right here, unravel it. So I'm going to draw this little picture to help anyone who's struggling to see what it is I'm babbling about. Hopefully my art skills are satisfactory for you. If I cut it open and remove the top and the bottom, and the outside of my cylinder were green, and the inside of my cylinder were, should I use blue? No, it's too similar, right? I'm going to use yellow for that other part. I guess I'll use yellow again. And the inside of the paper, so the paper was two different colors, one color on the inside and one color on the outside after it was rolled up. So now I'm going to finish opening this up. If I finish opening this up, it makes a rectangle. The back of this rectangle is going to be green. And the side we see right now, because the green flipped to the back, is yellow. Now, the area of a rectangle, we know it as base times height or length times width. And while that's not wrong, it's not that helpful right now. What do I know about this length right here? I know it's the base of the rectangle, but I want you to work backwards. This is this, which is this, and that is also known as the circumference, which is 2 pi r. This is at the height, nothing too sketchy there. So we have a circle, another circle, and technically a rectangle, right? That rectangle, base times height, really becomes 2 pi r h. So our surface area equation is pi r squared plus pi r squared, 2 pi r squared plus circle, circle, rectangle. The base times height, the base is really 2 pi r and the height is h. Now, could you just memorize that formula and not understand for a second where it comes from? I guess so. Will you potentially struggle? Yeah, potentially. So you really definitely want to be careful, okay? So there's our surface area formula. And now our volume, I'll put over here, and then we're going to do that example. The volume, here's a more general formula, like I mentioned. The volume of the base times the height, and then they wrote for us volume equals pi r squared h. So I know that it's 2020 now, and people don't really listen to CDs anymore, but CDs, a stack of CDs or a stack of plates, or even think of like a block of Post-it notes. Pretend we had circular Post-it notes in a big column, okay? If I found the area of one circular Post-it note, and I continued to stack them taller, 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 it's going to be a volume. So really what you do is you find the area of this base, whatever the shape is, circle, triangle, rectangle, octagon, pentagon, any shape. You find the area of the base and you multiply it by the height. And what that does is it takes that two-dimensional shape and gives it that 3D, that third dimension popping up out of the paper. So while the generic formula is area of the base times height, which is often represented with a capital B. Lowercase b is used for base, as in base times height of a two-dimensional shape. Capital B will normally represent the area of a base. Got it? Area of base, capital B. Specifically for this problem, that base is a circle and the area of that is pi r squared. So volume is pi r squared h. Now for the example. I gave us an example here where the length here is 8 millimeters as well as right there. Again, I'm going to redraw this picture and label it myself. So we have a cylinder. We're going to find the surface area and volume. I'm going to draw an oval, two parallel lines. Maybe again, I'll make them taller. I feel like the bigger you draw that's not the best oval. Oof, so flat on one side. I don't remember what I was just saying, but the bigger you draw your picture, the more space you have to label stuff. So it does come in quite handy. Now, the picture that I was given actually gives me the radius. The way it's labeled, that's the radius. So when I redo it, I'm sorry, diameter, that's the diameter. And I want the radius. So when I redraw the picture for myself, I'm going to go here and write R equals 4 millimeters, since the radius is half the diameter. Then I'm going to go right here. Not a T, it's like the line showing the distance from here to here. H equals 8 millimeters, and it's a right cylinder. This makes a right angle, standing up straight. It's not like it's blown over in the wind or anything. Also, the directions are going to be find the exact area. I'll explain what that means as we go along. Surface area equals circle, circle, rectangle. The circles are pi r squared, so we'll have 2 pi r squared plus the rectangle, which is normally base times height. However, the base is the circumference, 2 pi r h. Fill in to my equation. The surface area equals 2 pi 4 squared plus 2 pi times 4 times 8 which equals 4 squared, make sure you follow the order of operations, is 16 times 2 is 32. 32 pi plus 8 times 4 is 32 times another 2 is 64 pi equals 96 pi. Now this is volume. It's going to be millimeters cubed. And if you had plugged in your, oh, it's not volume, it's surface area. So I was just checking. I was like, that doesn't make sense. Millimeters squared, because it's a surface area. It's still area. If you plug millimeters into for the radius, you would get millimeters times millimeters, which is millimeters squared. And here you'd have 4 millimeters times 8 millimeters, which is 32 millimeters squared. Just like x times x is x squared, right? So the exact answer is 96 pi millimeters squared. If it asked for the approximate answer, in that case, you would do a decimal value and bust out your calculator. But when they want an exact answer, you leave your answer, what we call in terms of pi. In terms of pi means pi is in your answer. We're not rounding and we're being very, very precise. Now for the volume. The volume, as we just stated, is the area of the whole base, which is a circle, pi r squared, times the height. The radius is 4, so pi 4 squared times height, 8. Volume equals 16 times 8. That's the same as 8 times 8 times 2 for anyone who's trying to get better at mental math. So 16 is 8 times 2. I know 8 times 8 is 64. Times 2, it's 128. So 128 pi. Now that would have been millimeters squared times millimeters. So now we have millimeters cubed. And that's the end of the volume. So I hope this little explanation helped for the cylinder. I'm just going to highlight this, and I'm going to split these up into multiple videos. So at the end of this video, there should be a click through to go to the video for the next shape. Even if there's no shape on your worksheet that's a rectangular pyramid or whatever, doesn't mean you shouldn't learn how to do it, okay? Once you see how all of these prisms connect to one another, you will really be able to start to infer and figure out volumes and surface areas on your own. So good luck with the next volume and surface area. Bye.